Well, I'm in my own backyard and I see a star, and though I can't see it, I can imagine that it has a solar system forming around it, a galactic cloud, just like our solar system had. And there I see Dave Stange, and over there Steve Jokums. We all welcome you all. Hello, everyone. I'm Mark Marquette, and we welcome you to the American Space Museum as we are staying star curious with some backyard astronomy, some STEAM education, and some fun. As I always want you to look up and quit looking at your feet and the cracks in the sidewalk. Get outside, look up at the glorious stars that are above us, and you'll feel better for it. So, Marty Winkle is on the Streamlabs board. Marty, greetings to you, sir. We are in the week before Christmas. Everyone's getting busy, including myself, and we're going to have a week full of wonderful Stay Curious programs for you here, including Gary Allgaier talking about debunking hoaxers of the moon landing. All right. He's going to start doing that on Wednesday, and I'll promote that heavily on Facebook. Marty, good to see you there. Let's see who else is up there in our cyber world there. As you're going to see a planet, you're going to see a star in your backyard that has planets forming around it. All right. And looking around there, way over there is Cliff Watson. Hey, Cliff. He's in Pomona, Australia. And so stay tuned as we're going to take you on around the cosmos here on our Stay Star Curious, something we love doing. Let me take my volume off there. There, I'm going that way. Happy dreary Monday to you too, Carlton Bailey. We do have some kind of misty rain today, but gee, you can't complain when it's 65 or almost 70 degrees out, right, Marty? How are you? Say something on that UCAC family microphone.
Hello, Mark. Hope you're doing okay.
Good. Well, I might start talking about astronomy, so caution to that. Familiar mug to you. That was one of my Christmas gifts a couple years ago. Marty got me. Thank you, sir. Got yours on the way, by the way. So, got William Whiting's up there in Michigan, probably freezing. Dean Babcock, good afternoon to you all. We want to remind everybody it is the season for giving, and if you feel like giving the American Space Museum a tax-deductible donation, like Steve Jokums has done, and many of you out there, I know the UCX have, go to our website. Up at the top is a yellow donate button, and you can do it all different kinds of ways. And if you earmark it for Stay Curious, we're going to be spending money upgrading Stay Curious equipment next year as the funds allow. So we want to get you out under the stars. That is a planisphere. All right. As for how to find the planets against the stars, and that they're available. Great Christmas stocking stuffer for anybody up there interested in the stars. Go to your Books a Million or one of the other bookstores. Is that the only bookstore, Marty? There's Books a Million, and then there's something else. But
Barnes and Noble.
Barnes and Noble. Thank you, sir. Thank you, sir. And they will have what's called a planisphere. Looks like this. You put the date around the edge there, so in time. So I'm going to start observing at 7 o'clock on December 25th or December 16th, and that's how you look at these stars. And you got to wrap your head around it. It's just astronomy is not something that you just casually do. You really got to get into it, and put your educated BA master's degree on the thing there. So Dave Stange, he's got who's that beside you, Dave? Is that Mia, your little granddaughter there? Hi, Mia. I see you through my binoculars, okay? There she is. There's little Mia over there, 2 years old. All right. Maybe my grandchildren are watching. My daughter will let me know if they are. And Cliff Watson says it's been raining there for weeks as they're approaching the first day of summer. And the solstice is over the weekend, Marty. So we're going to have the winter solstice, and then December 22nd, and that's going to be the longest night, shortest day, and then we're starting getting on the upside to warmer weather. Uh, yes, planispheres are north and south hemisphere. Thank you, Cliff Watson, who's down the southern hemisphere. This would be worthless to him because it shows the Big Dipper, which you can't see from Australia. Uh, the stars are the same along the equator type of thing, but they're upside down. Good point. And if you got a question about astronomy, backyard astronomy, there's no silly questions. Please, please shout away there. But we are here on this green screen that Marty chose. This is what we think our Milky Way galaxy looks like. All right, with a black hole in the center, and you got a bar. This is a barred spiral. It's actually some sort of a longitudinal area where the spiral arms of stars are spinning off. All right, and we're about right here. And how far away is that from the center? Well, we're going to ask you that question here in a minute. Marty's question of the day. From our backyard, you can see down to about a third magnitude. And that's about right in the middle of this chart of showing you the Milky Way from the urban city, which you can't see, to where you go out to the suburbs. And astronomers are experiencing what we call sky grief or noctalgia because, believe it or not, throughout the year, you can only see about 135 stars in your backyard. I know that's true for my backyard in Port St. John. You're going to see just the stars down to about third magnitude. Now, if you were out in the desert on the far left here, that is sixth magnitude. All right, that's the human eye limit. And this magnitude stuff is a logarithmic scale. You mathematical people would enjoy that it's a 2.5 logarithm. So sixth magnitude is 2.5 times fainter than fifth magnitude. Or to put it another, there's only about 20 first magnitude stars out there, and they're 2.5 times brighter than second magnitude, which is 2.5 times brighter than third magnitude. So then you got your decimal points in between those magnitudes. All right. Gary Gerald says good afternoon, and good to him. Tom Usiak, we had some people in today from Pennsylvania. Where'd they say they were from? But they said that Lancaster, Tom, was right near them. So, and hi, Tom Celentano. We're going to talk about a star called Fomalhaut. All right. Fomalhaut is a bright star. As you look south tonight when it gets dark, you're not going to see any other bright stars in the south. It's going to look lonely by itself. It was actually called the Lonely One. But fomal means mouth in Greek, and that is the mouth of the southern fish, Piscis austrianus. And there you see the, take my name off there a second, Marty, if you could please, sir. Birds there. What is that? L? No, L's the top. Anyway, I want to show you the horizon at the bottom there where you see tree shrubs and stuff like that. So it's not very far from the horizon, high up, very bright star, Fomalhaut. And when you're looking at Fomalhaut, you are looking at a star that has a planetary system of dust, a ring of clouds around it. We can't see that with our naked eye, but it is wider than the moon, 2 moons, in fact, if we could see it with our eyes. But we're going to see it with the Hubble telescope and the Webb telescope, and that is the star system that you can see from your own backyard. You're going to see other things from your backyard, particularly with the transition to the fall, to the winter, really cold. This is the moon the other night. That's the planet Jupiter at the bottom left. This is a ring around the moon caused by ice crystals. This is a phenomenon that you're likely to see anytime that the moon is up. The moon just went past full, called the cold moon or Yuletide moon, Saturday. So it's going to be rising about an hour later every night. So if it, tonight it'll probably, I don't have my, yeah, I do. I'll get you what moonrise is on my app here in a second. But this ring around is 22 degrees on one side, 22 and a half. So it's a 45-degree arc. You can actually see a little arc inside there. And I see a cloud going across there like a contrail. The ancient Native Americans used to count how many stars were inside the ring around the moon, and that's how many days until it um, rains or something like that goes on. Well, the moon is just a day past full, so it's 15 days old. I didn't put that slide up there, but and it's in Cancer, and it's going to rise at 6:48 today, 6:48 p.m., about an hour after sunset, and then the next night, Tuesday night, it's going to rise at 7:54, and then on Wednesday 8:57 and Thursday 9:56. So see, it's about an hour later each time as it's going 1,000 miles an hour faster around the Earth and we're rotating. So it lapses every 29 and a half days. So keep your eye out for phenomenon in the sky. You can also see what are called um, big columns, light columns is what these are called. And these are caused by, again, ice crystals in the fog that put these light pillars off of our parking lot lamps and stuff like that at there. And this was up in Canada last night, somebody posted. The sun is still very active. It's at the most active cycle of this 11-year cycle between peaks and valleys. So this is seeing the sun without in a hydrogen light. You can't see this except with a special couple $1,000 filter. And look at the red on the side. That's a solar prominence, Marty. And this band right there is actually what a solar prominence is when you see it on the edge. So there's all kinds of flames licking off the sun, and that can throw energy out 93 million miles away. It goes all the way out to Neptune, is affected by the solar winds 2 billion miles away. And so just to give you an idea that when you look at our favorite star up in the sky, is going through a lot of turbulence like all nuclear reactions do. And that's what our sun is. It's a very small star, though, and we'll talk about that in a second. And I know some of you have been hearing about the Geminid meteor shower over the weekend, but you saw very few meteors because the moonlight is so bright that it washes out all but the brightest. But it's one of the most reliable meteor showers, just like the Perseids in August. But I didn't waste my time looking at it because the moonlight really, you're lucky to see one or two bright meteors in 4 or 5 hours of observing. But want to just acknowledge, yep, I knew that was going on. Watson's in Australia says 80 degrees and raining and high humidity. Now here's why we're having this reason for the season. The winter solstice is going to happen, all right, when we're at the equinox, the sun's higher in the sky, and the summer solstice is at its highest in the sky, as seen from the Earth because of the 20 and a half degree tilt that our 24 and a half degree tilt that our Earth is spinning off axis. How did that happen? Something hit us and knocked us over. Simple as that. And we don't know what that was, but Mars is also tipped over about 23 degrees. But this is why the days are short, simply because the sun is cutting a shorter arc across the sky, all right? And you'll never see the sun north of you looking at the North Pole. It's always going to be the south, see, unless it's directly overhead like it gets on that summer solstice. So 6 months from the longest day, now we're going to have the shortest day coming up on the 22nd this weekend. Here's an evening sky map I've encouraged you all to download for free. You just take it inside and study it for a little bit. The moon is near Mars on the 18th, which is Wednesday. So if you stay up late, on Wednesday it's rising after 10 o'clock, I think I said. Wednesday the moon is rising at 10 o'clock. And near it is going to be a bright red star, and that is Mars. And we'll have plenty of time to talk about Mars as it's in opposition or its closest approach to Earth in this 2 year cycle in February. The December solstice is the time when the sun reaches the farthest point south in the celestial equator, and marking the start of winter in the northern hemisphere and summer in the southern hemisphere. So, well, there you see the blue band going across there. That's actually the Milky Way. All right, the Milky Way is very prominent for a few hours in the uh, winter sky as it's setting in the west. But then over here to the north, you have a winter Milky Way that cuts through um, um, the W of Cassiopeia and above Orion. Okay. And and you can see some great features in that with the help of binoculars. So download this sky map for free. It is just that, skymaps.com, and it's got a wealth of information. Or go to your favorite bookstore or your Wally World and buy a Sky and Telescope or Astronomy magazine if you can find them. They're about $8 each, and they have a map inside a current what the sky looks like. Marty's trivia question of the day.
As Marky alluded to, how far is the sun from the center of our galaxy? Is it 300 light years, 3,000, or 30,000 light years?
All right. And that's what this looks like right there. How far is that if we are here in the center of our Milky Way's there? 300 light years, 3,000 light years, or 30,000 light years? Now, a light year is a distance a ray of light travels in a year. So we use distance to tell time now in space. And that's 8 trillion miles a ray of light goes at 186,000 miles a second. All right. It travels about 8 trillion miles. Now, that 186,000 miles a second sounds fast, but 93 million miles away is the sun. And light takes 8.5 minutes to travel 93 million miles at that incredible speed. So distances are very, very far apart in the solar system there. All right. There's our backdrop of the Milky Way and the Earth there in our merchandise area there in our gift shop. Wish we could see it like that, but we can see the thin blue line. So astronauts can't quite see it that clear, but they do get an impression of it with that. So we got some guesses there. Steve Jokums is 30,000 light years away, though astronomers are revising that. 24,000 light years, Cliff says. Yes, as we learn more, everything changes. But one thing that doesn't change, except 5 points of light in the sky, are the starry pattern that have stayed the same for thousands of years. Now, they do change because these stars are going just thousands of miles an hour through space, but they're so far away we don't see them change in their relationship to each other. So you go south tonight, you're going to see Fomalhaut is the brightest star, but Venus is going to be to the far right. And up above, completing a triangle, is Saturn. So you will see the Saturn very easily. It's a little bit brighter than Fomalhaut, but it will look Saturn will look yellowish, and Fomalhaut will look pretty white. All right, and Venus is just going to be a brilliant white, and we're going to talk about Venus as there's another photograph. I should take a photograph from my backyard. I'm lazy, not doing that. But there's Fomalhaut in the tree line, and there's the moon and Mars. And this was taken a couple years ago by an amateur astronomer. But I threw that in there to show you Fomalhaut. You can see under the moonlight, and it will be south. And above your tree line where you live, we're down here at 26 degrees latitude in Florida, so it's pretty high up. But Dave Stange's going to see it looking a lot like this in the trees where he's at. And then you think when you see Fomalhaut, cover it with your fist, arm extended fist, or no, with 3 fingers. And that's about 5 degrees. And this this gaseous interstellar solar system forming would cover up your three fingers there. It's amazing what we can't see. Again, Piscis australis, the southern fish. There is Pisces, the fish, not to be confused with it. This is a totally different constellation of the 88 constellations. You look through a telescope like I did the other night and take a picture. This is Venus. It is a half of a half of Venus is visible. It's between the Earth and the sun, just like Mercury, and goes through phases like the moon does, all right, because it's between us. So the sun is to the right, and this side's not getting any sunlight, all right. Now, what's going to happen over the next 6 months, actually next 3 months rapidly, is here is the loop that Venus takes in the evening sky. Think 30 minutes after sunset, it's 35 degrees latitude, about up there where Tennessee is. All right, this is called an apparition. It popped up into the sky in September and kept climbing higher, higher, and higher. And oh my gosh, you can't believe how bright and high it's gotten so quickly, as you see in the graph on the left there. You understand that, Marty? And so, see, January 1st, just a week away, a couple weeks away, it's not going to reach its highest point. It's going to reach its highest point in the sky on January 10th. All right. And it's going to kind of level off for about a couple weeks, and then it's going to start dipping down. And then down, boy, from March to the end of March, it's going to dip down quickly, very quickly. And where's it going? It's going in front of the sun and then pop up in the morning sky. And Marty, you're an early morning riser. You'll see Venus rising in the morning sky in late April. All right. And then it's going to start going behind the sun when it's in the morning sky. Well, this is a graph of how the size and phase of Venus will change from December 11th at the top. You see it in the middle to March. It is so dramatic to look at when it gets to be a crescent, and only 14% of it over my shoulder. The far side is how much of it's illuminated. All right. Well, December right now about 64% of it's illuminated. It'll actually be 50% or quarter phase January 10th. And then it really drops off as it becomes a crescent, yet it's still going to be brighter. All right, it loses just a little bit. It's this other column here, it's in Capricorn, Aquarius, Pisces, all right. The minus 4.4 magnitude, that's the brightness. Only the sun and the moon are brighter. The moon's about minus 12, the sun about minus 26 magnitude on this scale. But you see, when it does get to be just 14% of it covered, then it will dip down to closer to negative 4 on that. And gets all the way down to March 11th. It does not lose, it doesn't become invisible, but it becomes so close to the sun that you can't even look at it anymore. And then for a couple of days, we don't see it, though it's going to be in the daytime sky below the sun. Then it's going to pop up in the morning sky of April. All right, so let's talk about Fomalhaut. Fomalhaut has had various names ascribed to it over time. The Arabs, the Persians, and the Chinese all noted this star. It was where the solstice was in 2500 BC. All right. The star's traditional name of Fomalhaut comes from scientific Arabic, the mouth of the southern fish, literally the mouth. All right. And it's considered one of the 4 royal stars of the Persians. Now, the Persians are all about the Star of Bethlehem, and I'm going to talk about the Star of Bethlehem on Friday. Will be my final show. And we'll talk about the Star of Bethlehem. Not my the final show of the week, and then we're going to take off the Christmas week, except Friday. Uh, so I might do that on the Christmas week. Yeah, I'll probably do the Star of Bethlehem Friday because it has more meaning back then. Um, this is the first stellar system with extrasolar planets candidates was imaged in visible wavelengths. Okay, and since then, since 2019, and more observations have been made. All right. But as a star, it's a beautiful star. It's 25 light years away. All right. Uh, uh, since 1943, its spectrum has been known when they started doing spectroscopy. That's the fingerprints, if you will, of a star telling what it's made of. All right. It's the DNA of a star. It's more so than fingerprints, it's more of like the DNA. It is much hotter than our sun, 15 times as bright, uh, but it is blazing through its hydrogen at such a furious rate that it'll burn out in 1 billion years. All right. And that's about a tenth of the lifespan of our star. We think our star is going to last 10 billion years, and it's about halfway through that cycle. Stars are very different. It depends on how much material they started out with, called mass. How big did they start out with? Some of the bigger ones don't last very long. Um, very important in Chinese, its word in Mandarin, Belashaman, it means north gate of the military camp because this star is marking itself and stands alone on the north gate of the military camp of the military asterism, the encampment mansion. So this is part of a Chinese constellation that has an encampment mansion, is what it's called. And there's other things about Fomalhaut. Uh, Fomalhaut Earthwork B in Mounds State Park near Anderson, Indiana, lines up with the rising of the star Fomalhaut in the fall months, according to the Indiana Department of Natural Resources. So I bet you didn't know that. And it's a young star, thought to be only about 300 million years old. All right. Dinosaurs may have looked up and not seen this star. It was so young. With only a lifespan of about a billion years. And it's surrounded by several debris disks. Okay. It has an inner disk of high carbon, small grains of dust, and an outer disk that has a very sharp edge. And we're going to see that. Here's one of the earliest images taken in infrared showing the star in the center and a ring around it. All right. Other debris emanating from it. All right. This was a ground based telescope uh, in the early 1990s. The measurements of Fomalhaut's rotation indicate that the disk is located on the star's equatorial plane as expected from theories of star and planet formation. So the way this star is spinning, it's a little bit cocked to us with the North Pole facing us or South Pole. But let me tell you a little bit about exoplanets, all right? Since Fomalhaut was discovered as having a planetary system forming around it, other telescopes around the world started finding other star planets. Okay. And I'm not going to get too detailed into it, but these are not stars around our world. These are planets around our world. These are artist concepts of planets around other worlds. There are basically four types of exoplanets, and there's over 5,000 of them have been discovered. And we have found some of the nearest stars, Marty, all have other planets going around them. All right. So when you see stars in the sky, there are more planets going around those stars than there are stars in the sky. That's kind of interesting when you think about where's life and how different life are. So you got gas giants, bigger than they're twice, three times the size of Jupiter and Saturn. And some of them are very close to the star because the star is not very hot. You have others, so those gas giants are anywhere from 100,000 to 200,000 miles across. Neptune like are more in the 30,000 range, and those are the most that we've found. Super Earths are more 10 to 30,000 miles across, more like Neptune, but we think they have rocky bodies to them. All right, whereas Neptune sized exoplanets have a lot of gas, like Neptune, Uranus, Saturn, and Jupiter. Terrestrial means they're about the size of Earth, rocky, and could possess oceans and possess atmospheres. Okay, and yes, we can detect all this, and these are many of the exoplanets that have been discovered, different sizes, all the way down to scale. We're showing here. Some we have detected rings around them. This is not seen by photographic evidence. This is all inferred by the great scientific instruments that are on uh, astronomy telescopes around the Earth. Kepler orbiting the Earth. Kepler, in particular, is a one dedicated to finding exoplanets, and they have various techniques to do that. They can detect whether a star is being pulled left and right, so to speak, in gravity by the effect that planets have on them. So over 5,000 planets, pretty much divided up a third, a third, a third as far as giant ones, ones that are super Earth rocky, and ones that are Neptune and Uranus like. All right, big, but have a lot of gas to them. To the terrestrial ones, small rocky ones are uh, only 4% of the 5,000, so that's about 200 of them. But only one of that 200 has to have life in oceans like Earth to change how we think about everything. But that also, the smaller things are, the harder it is to detect them. So it's obvious that the smaller terrestrial planets are going to be less in numbers and for now. And again, another graph of the hot Jupiters. These are ones that are gigantic like Jupiter, but they're very close to the star they orbit. They're closer than Mercury and Venus are to our star. In fact, when we look at other exosolar systems, we haven't found one yet that looks like ours. We found about 300 of them, and all of them have the hot Jupiter big planets closer to their star, and the rocky planets are farther away. Don't know why, because our four rocky worlds are first in line to our star, but it could some of these stars aren't as hot as ours, so that they don't get all that heat. We know some lava worlds exist. We know some hot gas giants exist. We know there are worlds of oceans and gas, and we know that there are other exoplanets that have atmospheres on them. And the Webb telescope is trying hard to figure all that out. So here's how we detect them. A star moves away from us, light waves leaving the stars are stretched and move towards the red end of the spectrum. All right, you have eclipsing planets that actually pass in front of their star and dim that star's brightness. And then you have different ways that a star is detected using, again, this shows the spectral wavelengths. Potential habitable exoplanets ranked by distance from the Earth in light years. There's several very famous ones, the Gliese and TRAPPIST. There's a star that has about 8 planets going around it, like ours, and 4 of those, the TRAPPIST D, E, F, and G, all seem to have water on them and other things that could harbor life. So there's just a little graphic to give you some of these potentially habitable exoplanets, a lot of them close to the size of Neptune. Kepler was the telescope orbiting the Earth that found so many of these. There is a star, Kepler 452b, that has a planet going around it. There's one. So just to give you an idea of this is a fluid branch now of astrophysics that did not exist 30 years ago. So here we are in our solar system. How far away are we? 30,000, 300,000, or 3,000 light years from there? Again, here are some of the best candidates we have for planets that we know, like Earth, a little bigger than Earth. We know these planets have an atmosphere, and we know that we think they have surface water, thanks to the discoveries of the Hubble and the Webb telescope. So let's get back to Fomalhaut. Just in time for Mitch Rothman from Lake Wales, Central Florida, to say hi to you, Mitch. You go out in your backyard, you look up to the south, looking towards Miami, where I'm at here, looking down towards Mitch at Lake Wales, uh, outside of Buck Tower there near Kissimmee, Florida. And you're going to see a bright star. That star is Fomalhaut in the center. And around it is this gigantic cloud and ring of material, leftovers from when Fomalhaut was formed. And it's a distinctive ring. And the Hubble Space Telescope has imaged this ring. And from one end to the other is 2 moon diameters, folks. We could see this with our naked eye if it was bright enough, but it's not. It's not. We couldn't see it with the giant telescopes like the Hale telescope, a 200-inch. We had to use modern technology and stuff. But there's Fomalhaut in the center, and there's a dust ring that goes around it with clumps in it. And this is a suspected planet in the inset, and where it has moved in 8 years since the Hubble was watching it. It's moved further since then, and they call it Fomalhaut Planet B. Now, there's been some recent speculation that maybe it's not a planet, maybe it's just a forming, maybe it's just a loose, an impact area of where something, exo asteroids hit each other. But we'll figure that out as time goes on. Another image of this star showing you the tremendous amount of dust and rings around it there. It's just amazing. It's just incredible to think about this, that this exists on a scale of thousands and thousands of stars. This is going on. Yet you can't tell it by looking at old Fomalhaut. And here's the Webb telescope image of the dust ring around it in the clumped areas. Where is this a planet forming there out of the dust? Is this another planet forming around this ring? Is this the Kuiper belt where Pluto exists? All right, in there. This is a very close star to us. This is in our backyard, literally in your backyard tonight, but our Milky Way backyard 25 light years away. And here's another star that the Webb telescope has investigated, just to show you that it has found planet going around this star called Hipparchus, after the an analysis by the Hipparchus telescope orbiting satellite. So I hope you've enjoyed looking at your backyard at a primordial solar system undergoing its throes of violence as things are smashing into each other, things going on that started in our early solar system 5 billion years ago, and then did things like mar up our moon with hundreds of thousands of craters and so forth. So hope that you've all enjoyed this today. I think I said hello to everybody. I'll say hello. Thank you, Mitch Rothman and Gary Gerald and Tom Usiak, Tom Celentano, Dean Babcock, Bill Whiting, Carlton Bailey, Cliff Watson, Steve Jokums, and Dave Stange for shouting out there. And let me just get little Mia back in there. Hi, Mia. I see you there with Grandpa next to the tree there. So we'll throw some Christmas trees in from your living room tomorrow's show. Send me some pictures if you got any. Out there. And Marty's question, how far is the sun from the center of our galaxy, Marty?
Well, Steve Jokum said 30,000, and then he came back and said many astronomers are now saying we're 26,000 light years. And Cliff Watson said 24,000 light years. So our number is 30,000 light years.
All right.
Same as Steve. But 24,000, 26,000. That's probably
Right. They
close.
know it's further than 3,000. They know it's very close. And we're talking about the distance from where we are in our humble solar system. All right. And 25 light years is not even outside that blue there with our stars there. But this is about 30,000 light years to the center. Now, we didn't know this, and this is not a photograph. This is an artist's conception, of course. But where you see the red, this is a young galaxy. Our galaxy is very young because the red is where new stars are forming. And where there's new stars, we know there's planets. So we've got 100 billion with the B stars in our Milky Way galaxy, maybe 200 billion. They can't count it. It takes too long. But it is a lot. And when they say more grains of sand than are on all the beaches of the world, that's what they mean. It's amazing how many stars are in our own galaxy. And then the Hubble telescope and now the Webb telescope has shown us hundreds of thousands of galaxies out there, small, big, all kinds of ways out there. So get outside there and go check out Fomalhaut, looking like this. Go find Venus, pan to your left until you see the next bright star close to the horizon. That's Fomalhaut. Go straight up. That's the planet Saturn. Enjoy some stargazing. Get away from the riffraff of the holidays and clear your head like I do in my own backyard. So, hope that you all enjoy another episode of the American Space Museum STEAM program, Backyard Astronomy, with me, Mark Marquette. And I look forward to seeing you all again tomorrow with Marty, as we're going to have 4 more great shows this week, including Gary Allgaier on Wednesday, taking on the moon hoaxers in a way that only Gary can do it. So until tomorrow, I'm Mark Marquette saying I can't wait to see you again to bridge the space between us.